Okay, try number 3 is the best. So what's going to happen here is we are going to show the addition of hydrochloric acid to my alkene, which happens to be ethene in this case. So as you saw in the previous slide, your double bond is going to act as your nucleophile. So I'm going to call that NUC for nucleophile. And the hydrogen here is going to be your electrophile. I'm just going to put ELE to represent electrophile. So the nucleophile, the double bond, the pair of electrons in the double bond is going to act like your nucleophile and attack the hydrogen. The hydrogen is going to give one of its electrons back to the chlorine. And so in this next step, you're going to see that the hydrogen has bonded with one of the carbons. And you will have another carbon here that is missing something because the double bond broke, and so you'll have a positive charge on the carbon. What we call this carbon, because it is missing something, is a carbocation. It is a very highly reactive electrophile and is waiting for a nucleophile to attack it. Luckily, it has a really good nucleophile in place, being the chlorine, that now has a negative charge since the hydrogen has given it back an extra electron. So now what's going to happen in this next step is this chlorine is going to attack the carbocation, and you will end up with a chlorinated alkane, in this case, chloroethane. This is an addition reaction because you added a hydrogen and a chlorine to an alkene. We call this step here, we call this an intermediate. And the reason we call it an intermediate is it's what happens until we get the final product. Sometimes intermediates don't last very long. Sometimes intermediates go on for quite a while. We call intermediates also the rate determining step, meaning how long the intermediate stays stable will dictate how fast or how slow the reaction goes. So this is your first example of an addition reaction. Sorry for the chicken scratch, and hopefully that makes sense.